Hello, I am Ziqing, and I am going to present my FYP project, POI recommendation on uncertain check-ins. First, let me introduce what is POI recommendation. It is a function widely used on location-based social networks. A good example of location-based social network could be Foursquare, a local search and discovery mobile application that allows users to share location-related content and explore locations nearby for various social activities. POI recommendation system will predict point of interest which a user might be interested in, but considering users' preference and common behavioral patterns. A good recommendation function could improve the user experience and the client's sales revenue. The current POI recommendation system assumes that the user's check-in history is accurate. However, it may not be true all the time. Sometimes, we may only know the rough position of the user, but not which POI he actually visited because of the nature of data recording mechanism or the inaccuracy of the data recording process. To better illustrate this problem, let us take a look at an example. Bob drove from P1 to Mall P5. The GPS trajectory was captured, and the stopping point of Bob was at the car park of Mall P5. However, we do not know if Bob visited P2, P3, or P4. The history data was incomplete, and we want our system to give as accurate as possible recommendation given this uncertain check-in scenario. We call each specific POI individual POI and POI cluster such as Mall P5 a collective POI. Next, I will discuss the data preparation process. For this project, we used check-in histories from two public datasets from Yelp and Foursquare, and we selected 3 cities which has relatively high data volume in both datasets. We then processed the data and extracted visit sequences for each user. The amount of data after processing are shown in a table below. Due to the time constraint, the details of the step will be omitted. For a visit sequence V1 to V2 to V3 to V4, 5 parallel sequences are generated. The POI sequence records the category of the visited POI. If the POI is collective, there is no single category. We will replace it by a category distribution within the collective POI. The time sequence records the time of the visit. The type sequence records whether the POI is a collective or an individual POI. The distance sequence records the distance between the current POI and the previous POI. This is the structure of our proposed model, IMDL. It has 3 parts, and we utilized 2 LSTM modules to learn the sequential information of a user's visit sequence. I will discuss each part separately. The first module is called the TemporalAware activity encoder. Its task is to predict the user's next category of visit, or we call it activity, because the category captures users' intention on the next activity. Its input is category, time, and type sequences. The 3 inputs are assigned different weights and added into one vector as the input of the LSTM. We then use the output of the LSTM to calculate the scores for each category and each type, and predict the category and the type of the next POI in the later module. It should be noted that for collective POIs, it does not have a single POI, a single category, and we do not know which category the user actually visited. Thus, we replace its category by the category distribution within the collective POI. For example, Mall L11 has 1 POI of category 1, 2 of category 2, and 3 of category 3. The category embedding of L11 will be a weighted average of C1, C2, and C3. The second LSTM module is called the Spatial-Aware Location Preference Encoder. Its task is to capture the location-related information, and its inputs are the POI and the distance sequence. Lastly, the output of the 2 LSTM modules will be put into a task-specific decoder. We use the output of the first LSTM multiplied by each category or type information to predict the next category and next type with the highest score. We then concatenate users' information, users' intention, time information, and spatial information together to calculate the score for each POI and predict the next POI based on the highest score. If the predicted POI is a collective POI, we will select all individual POIs with the predicted category, for example, all restaurants in the mall, and give predictions based on the highest rating under the predicted category. For the model training, we sampled 5 POIs which the user did not visit in the real case. We call it negative POI. We calculate the score for the correct POI as S and the negative POI as S prime. We then make the score for the correct and negative POI as different as possible by minimizing the formula below. To measure the effectiveness of the score, we did experiments on TensorFlow and compared the results with the 8 state-of-the-art models listed in the slide. We evaluated the results based on mainly 2 values, the recall and the mean average precision, which is another measure for precision for multi-class classification. The experiment results are shown in the table, and we can see that our IMTL model outperforms other models when predicting the activity and the POI under this uncertain checking scenario. What is more, 4 model variants were tested, but due to the time constraint, it will not be covered here. That would be all for this video. Thank you very much.